Rutherford model of atom didn't explain about, okay, when an alpha particle is incident on heavy nucleus, okay, why alpha particles does not, why alpha particles does not travel in a single direction. Okay, it explains about alpha particles will scatters in all the directions. Due to that, each alpha particle will have different wavelength, different wavelength. So that is, whenever alpha particle is incident, both the electrons will have the same energy. But due to the scattering, the electrons will have the different energy. Due to that, okay, the emission of electrons, okay, emission of electrons will travel in the different directions. So it will have different wavelengths. Okay. Whenever the two electrons are having the same energy, it should have the same wavelength, right? According to the formula, E equal to h nu, that is hc by lambda. Hc by lambda. Okay, that is number one. And number two, Rutherford didn't explain about whenever an alpha particle is incident on heavy nucleus, how much energy will be lost, okay, by the heavy nucleus, or how much energy is gained by the heavy alpha particle. He didn't explain. He didn't explain about energy lost or gained. Okay. Okay, like this we are having. So with respect to this energy lost or gained, Bohr explained the process called either absorption and emission, comma, emission. Okay, here we are having the postulates of Bohr's model of atom. Okay, most important one. Okay, Bohr considered that electrons are revolving around the nucleus in circular orbits. In circular orbits. Okay, Bohr considered that electrons are revolving in around the nucleus in circular orbits. Okay, that is number one. And number two, okay, and number two, okay, second one it is, suppose I'm having a nucleus. Okay, suppose like this, I'm having a nucleus. Around the nucleus, here I'm having an electron. Okay, suppose let us consider it is the electron in the 1s orbit. Okay, and here it is the 2s. Okay, so here we'll have the 2s, and this is radius of the first orbit. Radius of the first orbit I'll call it as r1, and radius of the second orbit I'll call it as r2. Okay, now whenever an electron is revolving around the nucleus, okay, Bohr considered that angular momentum of the electron, angular momentum of the electron is constant. Angular momentum of the electron is constant. So that is angular momentum means mvr. Usually in vector form means we'll write it as L bar equal to R bar cross P bar, where P bar is equal to, it is linear momentum, okay, M into V bar. He considered that the angular momentum of an electron is integral multiple of, that is n into h by 2 pi, where h is the Planck constant. Pi is having a value 3.14 or 22 by 7, where n starts from 1, 2, 3 and so on. This can be called as integral multiple, n equal to 1, 2, 3. It won't have any decimals. It won't have any decimals. And next, third postulate is whenever an electron, okay, is excited. Suppose here I'm having suppose two electrons are, okay. Upon application of energy, or whenever we supply an energy, then the electron will move from the ground state to the first excited state. First excited state. This process we can call it as an absorption. This process can be called as absorption. That is, whenever an electron moves from lower state, lower energy state to higher energy state, next higher energy state can be called as absorption. Okay, absorption. Okay, it is moving from lower energy state to the lower state to higher energy state or next higher state. Similarly, whenever the electron loses the energy in its first excited state, okay, then it will comes to the ground state. Here, with the supply of energy or without the supply of energy, okay. Suppose electron loses all its energy, then directly it will come down. Say, for example, in mechanics, there is a chapter called kinematics. If you see we'll study a topic called motion under gravity. Whenever we apply a force, then what will happen? Object will goes to maximum height. Okay. Now, all the kinetic energy will be converted to potential energy. Whenever all the potential energy is utilized, then the particle may come to the ground. Okay. That is, with supply of energy or without the supply of energy, an electron in the first excited state may comes to the ground state. This process we are calling it as emission. This process we are calling an emission. That is, from higher state to next lower state or lower state. Okay. Suppose here I consider that it is first excited state to the ground state. To the ground state. Okay. Manish. ఇక్కడ కూర్చో ఇక్కడ కూర్చో నెక్స్ట్ హైయర్ స్టేట్ ఓకే చెప్పలేదు చెప్పలేదు okay, absorption process and emission process. Okay, these three are the postulates. Okay, these three are the postulates. Okay, okay, fine. Keep the side heading as in your notes as Bohr's model of an atom. All of you, please keep the side heading as Bohr's model of an atom. Okay. Bohr's model of an atom. Okay, no? All of you get. All of you get. First postulate right over. An electron revolving around the nucleus. An electron revolving around the nucleus. Will circulate in circular orbits. Circular orbits. Will circulate in circular orbits. Circular orbits. Completed?
Yes, sir.
Next point, second one. When an electron is revolving, in circular orbits, in circular orbits, then the angular momentum of the electron remains constant. Then the angular momentum of the electron remains constant. That is, write down this expression. L equal to mvr. That is equal to nh by 2 pi, where n is equal to 1, 2, 3, and so on. Issue 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 Kelvin issue 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 okay, completed. If you want, you can write this relation. That is relation between angular momentum and linear momentum. Okay. Okay. Next, third postulate. When an electron absorbs an energy, absorbs or receives an energy, absorbs or receives an energy, then electron will jumps from electron will jumps from lower state to next higher state. Lower state to next higher state. Okay.
Yes, sir.
This process can be called as this process can be called as this process can be called as absorption. Absorption. This process can be called as absorption. Okay. Similarly, when an electron jumps from higher state to next lower state, next lower state, next lower state, with the release of energy, with the release of energy can be called as emission, can be called as emission. Okay, completed. Can be called as emission. Completed.
Yes, sir.
Yes, sir.
And all of you must remember these three postulates. Okay, in the IP exam, especially these postulates, they are asking 2 marks. And entire this question, they are asking for 8 marks or 4 marks. Most important derivation. And even in the entrance, they are asking on this Bohr's model or hydrogen spectrum 1 question. 1 question. You can easily score. Okay. Okay, fine. Next, come to our theory. Okay, that is, we are having a nucleus, suppose like this. Okay, around this nucleus, we are having an orbit. In this orbit, an electron is moving. That means I am considering in this orbit only one electron is there. So the charge of an electron will be E. Whenever it is nucleus, okay, we'll have the jet number of protons will be there. Jet number of protons. So the charge of the nucleus, it is Zt. So whenever there is an electron is revolving around the nucleus, at every point we'll have a centripetal force will act. We'll have a centripetal force. So there are the two forces will act. One is centripetal force. Okay. And another one it is, both are charged particles. The nucleus and as well as the electron. Both are charged particles. So there will be an Coulombic force. Centripetal force is acting towards the center of the atom or towards the nucleus. Whereas this Coulombic force Okay, Coulombic force will acts. Okay, we can say it is attractive force will acts outwards. Okay, since here you can see whenever there is a force is acting inwards, there will also be a force which will act outwards or centrifugal force. That mg is balanced by the centrifugal force. And all of you remember mass of electron. What is the value of mass of electron? 9.1 into 10 power minus 31 kg. All of you must remember this value. Okay. So in order that electron must revolve in its orbit, centripetal force must be equal and opposite to the Coulombic force. Centripetal force that is acted by the electron. So it is mv square by r, where r is the radius of the orbit. Where r is the radius of the orbit. Okay, that is given as Coulombic force. Let us consider first particle, it is nucleus, Q1 equal to Ze, and second particle it is electron. So what is the formula for Coulomb's law? Coulomb's force formula.
K Q1 Q2 mass.
K means
1 by 4 pi epsilon.
1 by 4 pi epsilon naught. Okay, Q1 Q2 by r square. Okay, so I can write it as mv square is equal to 1 by 4 pi epsilon naught Q1 Q2 by r. So v square is equal to 1 by 4 pi epsilon naught Q1 Q2 by r, called as equation 1. Since in the Bohr's second postulate, you can see mvr is equal to nh by 2 pi. From this, I can write v. Since mvr is equal to nh by 2 pi. nh by 2 pi. That implies v is equal to nh by 2 pi mr. Right? So, from this, I can write it as v square is equal to n square h square by 4 pi square m square r square, called as equation 2. From 1 and 2, see, left hand side it is same. So n square h square by 4 pi square m square r square is equal to 1 by 4 pi epsilon naught q1 q2 by r square. Q1 q2 by r, not r square. Okay, so here we can write as one time get cancelled. N square h square cross multiply epsilon naught r is equal to 4 pi m square r square.
Sir, 8th class के 8 के साथ के 8 class हो
8 क्या వీళ్ళది ఎక్సెల్ జూనియర్ మ్యాథ్స్
junior inter
కంబైన్ క్లాస్ దేనికి ఏమైంది నేను మెసేజ్ పెట్టాలా ఏమని
8:30 ఏమని పెట్టాను మ్యాథ్స్ క్లాస్ 8:30 అని పెట్టాను చాలా
ఒక నిమిషం ఏమప్పుడు మ్యాథ్స్ క్లాస్ 8:30 అని పెట్టు అది మేడం
లింక్ సార్ మ్యాథ్స్ క్లాస్ లేదా
8:30కి మేడం
8:30
వెంటనే 9కి ఏమైనా ఉందా క్లాసు
9కా ఉందిగా
కెమిస్ట్రీ ఉందా సరే సరే అయితే
హాఫ్ అన్ అవర్ తీసుకోమన్నాను ఏం చేస్తావు
ఏది మేడం
హాఫ్ అన్ అవర్ తీసుకోమన్నాను ఏం చేస్తావు అంటున్నా
సరే సరే
ఓకే
ఒకసారి సార్ సిస్టమ్ ఆన్ చేసి చేస్తే నేను వచ్చి దాని సంగతి చూస్తాను. సో హియర్ R is equal to n square h square epsilon naught by 4 pi m. Okay. Here Q1 means Q1 Q2. We consider that since Q1 is equal to ZE and Q2 is equal to E. So R is equal to square h square epsilon naught by 4 pi m Q1 Q2 means ZE square. That is, we can write it as R is equal to h square epsilon naught by 4 pi m E square times n square by z. N square by z. Suppose if I want to find radius of an electron in the first orbit in hydrogen atom, then z equal to 1. Hydrogen atom, z equal to 1. Okay, n is equal to 1. N is equal to 1. Okay. ల్యాప్టాప్స్ ఆర్ పట్టుకుని వెళ్ళారు కదా, అది యాపిల్ కూడా లేదు కదా ఇప్పుడు మన దగ్గర. అయితే మనం ఏం చేయలేదు.
నాకు చెప్తారు ఇంటి దగ్గర ఏముంది, ప్యాడ్ అన్నీ ఉన్నాయి కదా.
లింక్ పెట్టాలి కదా,
సార్ ఫోన్కే కదా.
So suppose if it is first orbit, I can write as h square by epsilon naught 4 pi m E square. Okay, for hydrogen atom, radius of an electron in the first orbit for hydrogen atom. Here all are constants. You can see h, what is the value of Planck constant? 6.63 into 10 power minus 34 joule second. Epsilon naught, what is the value of epsilon naught? 8.85 into 10 power minus 12 units. Coulomb square by Newton meter square. వాల్యూ ఒక్కటే కాదు, యూనిట్స్ కూడా కావాలి. m means mass of electron. It is 9.1 into 10 power minus 31 kg. E, charge of electron, that is 1.6 into 10 power minus 19 coulomb. Okay, fine. So R1 is equal to h square epsilon naught by 4 pi m E square. That is, calculate this value, 6.63 into 10 power minus 34 whole square into 8.85 into 10 power minus 12 divided by 4 into 3.14 multiplied by 9.1 into 10 power minus 31 into 1.6 into 10 power minus 19. Calculate this value. చెప్పండమ్మా.
కింద ఈ స్క్వేర్
m E square కరెక్టే కదా. అంటే 6.63 into 6.63 43.956 into 8.85 into 10 power minus 68 multiplied by 10 power minus 12. Okay, divided by 4 into 3.14 multiplied by 9.1 multiplied by 2.56. That is 292.5977. This one 10 power minus 31 into 10 power minus 38. So 43.9569 into 8.85. That is 389.0185 divided by 292.5977. 10 power minus 80 by 10 power minus 69. 389.0185 divided by 292. Okay. ఇక్కడ మిస్టేక్ చేసాం. 4 pi. Okay, 4 pi square na. 4 pi square. 4 will not come now. 4 will not come. Pi. Four will not. So this value will be 3.14 into 9.1 into 2.56, 73 point 73.149. So 389.0185 divided by 73.149. That is 5.318 into 10 power minus 11 meters. So the radius of the first orbit, it is 0.5318 into 10 power minus 10 meters. So radius of the electron, it is 0.53 angstrom units. So radius of the nth orbit, we can write it as, okay, we can write it as, see, enter this value. This is 0.53 angstroms. So we are writing as 0.53 into 10 power minus 10 multiplied by n square by z. N square by z. Okay. Remember this formula. From this, we can say that radius of nth electron is directly proportional to square of the principal quantum number or energy of the orbit. And as the atomic number increases, radius will be decreases. Radius will be decreases. Okay. Keep the side heading as, derive an expression for radius of an electron. Derive an expression for radius of nth electron. Okay, start writing from here. Okay, completed.
Completed, sir.
Put this equation in the box. Okay, over.
Completed, sir.
All of you completed?
Yes, sir.
Okay, over. Okay, over.
Yes, sir.
Okay, now we know that radius of the nth electron is n square h square epsilon naught by pi m z e square, right? Okay, see, n square h square epsilon naught by pi m z e square. Now I want to find velocity of electron in the nth orbit. Till now we found radius of electron in nth orbit. Velocity of electron in nth orbit. Since we know that mvr is equal to nh by 2 pi. Okay, so mv into r I can write as n square h square epsilon naught by pi m z e square is equal to nh by 2 pi. So here pi get cancelled, will get cancelled, and one time nh. So v into nh by epsilon naught by z e square is equal to 1 by 2. So velocity of electron in the nth orbit, I can write it as z e square by 2 nh epsilon naught. The same equation I will write it as e square by 2h epsilon naught times z by n. So velocity of electron in the velocity of electron in nth orbit is direct z by n. See, as the principal quantum number increases, radius of electron will be increases, but velocity will be decreases. Velocity will be decreases. Okay. Now find the value of e square by 2h epsilon naught. E square by 2h epsilon naught. Substitute the values. That is 1.6 into 10 power minus 19 whole square divided by 2 into 6.63 times 8.85 into 10 power minus 34 into 10 power minus 12. That is 2.56 into 10 power minus 38. What is the value of denominator? 2 into 6.63 multiplied by 8.85. How much? మీరు క్యాలిక్యులేషన్ చేస్తేనే చాప్టర్ వస్తుంది, మీరు చేయకపోతే రాదు. ఫిజిక్స్ మార్కులు రావు అంట, అందుకే రావు. 2.6 into 8.85, 117.351 into 10 power minus 46. That is 2.56 divided by 117.351. That is 0.02114 into 10 power 8. 10 power 8. So that is 2.18 into 10 power 6 meter per second. Meter per second. Okay. E square by 2h epsilon naught. So velocity of electron in nth orbit, it is 2.18 into 10 power 6 into 10 power 6 into z by n. See here, this entire value, it is 2.18 into 10 power 6. That is, every time you need not to calculate this value. If you know the number of the orbit or state of the orbit, you will find n, small n, and atomic number we will know. Okay, this one. Okay, fine. With respect to velocity, I want to find kinetic energy, potential energy, and total energy. Okay. Kinetic energy, I can write as half mv square. That is m by 2. V means we know. Here we are having the formula. That is E square by 2h epsilon naught. E square by 2h epsilon naught into z by n whole square. That is m by 2 into z square e power 4 by 4n square h square epsilon naught square. Okay, that is m z e square power 4 by 8n square h square epsilon naught square. That is the kinetic energy. Now I want to find the potential energy. Okay. Potential energy is defined as energy required by the electron to interact with the nucleus. Energy required by the electron to interact with the nucleus. So, by definition of potential energy, we can write as U is equal to minus integral F times dr. Okay, potential energy is indicated by U. So, U is equal to minus integral 1 by 4 pi epsilon naught ZE into E by R square. Okay, dr. Integrate it. Okay. వెంకటేష్ అది అయిపోయినాక ఒకసారి రా. ఓకే, ఇంటిగ్రేటెడ్. ఇది ఛార్జింగ్ పెడుతుంటే దీంట్లోంచి మంట వస్తుంది.
ఎక్కడ
ఇటు మంట వస్తుంది.
వచ్చిందా ఇప్పుడు?
వచ్చింది, అందుకే భయం వేసి తీసాను. కానీ
వచ్చిందన్నమాట. ఎక్కడ?
ఇట్లా కంచి మంట వచ్చింది. కాలిపోయిందా అంటే ఇప్పుడు మనకి ఛార్జింగ్ కాదా?
తీసుకొస్తాను.
minus 1 by 4 pi epsilon naught ZE square integral 1 by R square dr
1 by R.
minus 1 by 4 pi epsilon naught Z E square into minus 1 by R. So 1 by 4 pi epsilon naught Z E square by R. We know the value of R. We know the value of R. I substitute it. That is U is equal to Z E square by 4 pi epsilon naught into 1 by R. Since R is equal to N square H square epsilon naught by pi m Z E square. That is U is equal to Z E square by 4 pi epsilon naught 1 by N square H square epsilon naught by pi m Z E square. Z E square by 4 pi epsilon naught into pi m Z E square by N square H square epsilon naught. So pi get cancelled. Okay, any other term? Potential energy will be, okay, and here it is plus, this one plus, and here it will be minus Z E square into m Z E square divided by 4n square H square epsilon naught square. So potential energy U equal to minus m Z square e power 4 by 4n square H square epsilon naught square. Okay. Okay. Kinetic energy it is, see,